Quickly, just like I said, go over overview with you, just a little bit more about Zachery, what we do and who we are. Our vision statement, just to present it with you. We're known as a principle-based enterprise which combines the best in people and technology to create a special business experience, seeking always to make a difference. Okay, so who is Zachery? We're a privately held company that's been in business more than 85 years. We focus on long-term relationships, and we're one of the largest direct hire merit shop, EPC, and maintenance contractors in the United States. EPC is engineering, procurement, and construction. So we've got capabilities of all projects that we're involved with of doing the whole thing. What do? We plan, we build, we renew America's most critical energy and industrial facilities. Our reputation is safe, reliable, on time, on budget. The complex projects. Our customers in the industry are industrial, refining, chemical operating companies, public utilities, and private energy developers. Within Zachery, we've got several companies. The first one, upper left-hand corner, is Zachery Industrial Inc. As you've seen around town, you've probably seen the name Zachery. This is our construction arm. That's where the company started. Zachery Engineering Corporation, that's who I'm associated with, along with several folks in here. Zachery acquired an engineering company in 2005, 2006 time frame. They've also acquired Zachery Nuclear, about the same time frame, so we do nuclear projects. We also have our own staffing through Precision Resource Company. They hire folks for us as well as others across the United States. And just last year they acquired a JV industry company. They primarily focus on process industry. So when we're talking about Zachery, we're talking about the whole group here. Currently, they employ in excess of 20,000 crafts, professional, supervisory, technical, and managerial personnel. This year alone, they plan on exceeding $2 billion in revenue. We're planning on working more than 30 million work hours as a company. We'll be on approximately 100 sites throughout this year, doing different projects. And we have about 30 locations across the country where we have regional office, where we have employment, training facilities, and design centers.
I've got an associate's degree in manufacturing engineering technology. Started out on the manufacturing side, worked at Kawasaki for 10 years, and then landed a job in Omaha in a power company called APA. I've been doing this about 25 years. When I started there, we're on board. But back then, as a drafter or designer, I mean, engineering, talking to an engineer was against the rules. I had to go through my boss. So over the last 10 years, it's really shifted where they've opened it up. You know, I don't want to say it, but they always look down their nose at me, you know. But I mean, but you're right. A paradigm shift is it's more trust now.
More trust, yeah, that's great.
And they're all very capable. This one here, what they call a spring, it actually allows the pipe to move up and down. This little piece right here is a spring. And then as the pipe heats up, it'll allow it to go up or down. Actually, it can move up too. There's another Pythagorean theorem right there. That little cantilever on the hanger. Again, the software has made life really easy, but it is really important for those students to know how to do all of that.
Plug it in up here. And we already said we're going to hold our velocity to 10 feet per second.
It's more of an average, not like
3, 5, 2, 6, 4. Feet square. So we've got our area now. we go ahead and solve for D. We wind up with 645 feet. Pipe doesn't come in foot dimensions in the diameter until you get really big. We don't want it to be that big anyway. So we wind up with 7.74 inches. That's the diameter of pipe we would require to cool this, to put this much cooling using water going from 95 degrees to 105 degrees. So what I do is I go to a table of prescribed sizes. We know that there's 4-inch pipe, there's 6-inch pipe, there's 8-inch pipe. And each of those have different wall thicknesses that we can pick from. So we go, and in the problem here I stated that we wanted to stick to a carbon steel pipe, that'd be a standard pipe, and a Schedule 40 pipe, that'd be a standard schedule that you'd be able to pick from. It would be on the shelf somewhere. And you would go to that table and you would find basically what's the next size up that meets that. So it happens to be an 8-inch Schedule 40, has a diameter of 7.981 inches. That's an industry standard. So he would say, I'll sell you this for $1 a foot instead of $1 million a foot. And I'd say, that sounds like a great deal. And we'd buy that, and we would know, since it's bigger, we're going to get a little more flow through. It's going to be a little bit cooler. We got a little margin added to it. So we're good.
In our field, in our industrial construction field, we do a lot of it with inches and a lot of it with linear footage. So what we do is break it down, you know, an inch is going to be in a tenth or in decimal, so 0.08, and then 0.25 is 3 inches. So a lot of our measurements deal with a lot of big numbers, but we kind of break it down in our industry to make sure we understand more accuracy in our field. Doing the calculation on a linear footage or on a square footage on forms, and we use that very handy in our field with our supervisors and our materials. That we do a lot of takeoffs. What's the amount of materials or concrete volumes and things like that, like reinforcement and rebar that we do. Just the similarities, just the shapes. You know, this cylinder, you know, we build tanks. So kind of triangle, we use a lot of Pythagorean where we use a lot of the bron or rice. And then our rectangle, we use a lot of a square surface, you know, where we're doing some ponds, or we're doing some fine grading, or we're doing some landscaping as far as sodding. So we need to make sure we order the right material. We don't want to be under, nor we're going to have a surplus. So we just kind of stay in a budget. And also we also ordered maybe an extra stuff just to make sure we don't come up short, you know, on the circumference on the tank. Sometimes we just do the tank on the area paving, which is just a concrete surface, so we just need to take the volume instead of doing the wall. And octagon or hexagon also do some of the major foundations that we do in the tank. So we do a lot of it on a daily basis, and mostly of some of our plants, sometimes they have some of the complexity and some of the structure foundations that they're designing. We just gotta apply what we know, or get with the engineers and see what the best way to get the more accuracy and the most benefit, so we can be in the same page. So that's right there. That's a steam turbine foundation. Those are the pedestal, the columns. As we can see, we have a major footing first. We do this one, and that's like a massive concrete pour. So it's about 100 by 50 by 5 foot. So everything is done in cubic yards. So we got to do the surface, the length plus the surface. I'm gonna jump over here. Not a very good drawer, but typically that's what the whole steam turbine foundation. So we got to get in cubic yards and find out the volume of the concrete. So what we do, it's 27 cubic feet. It's equivalent to 1 yard, and we do the length times the width, and then times the depth of the foundation. For example, we do this one. It's going to be 100 feet by 50 feet, and the depth is 5 foot. So, and then that all that is going to be divided by 27, or sometimes those I have a calculator. that somebody can do it. This one right here is a construction calculator. Let's see. We can do the 100 by 100 feet by 50, and then by nowadays they have a construction master calculator that you just press the key on the yards, and that'll give it to us as far as the volume.
925.9.
So those are that's the volume that is gonna take that foundation, this one, and then on top of the other one, then we'll gotta come in and do the volume on the columns as well.